Bismillahirrahmanirrahim. Uh, to communicate one bit of information reliably, cellular phones transmit the same binary symbol 5 times. Thus, the information 0 is transmitted as 00000 and 1 is transmitted as 11111. The receiver detects the correct information if 3 or more binary symbols are received correctly. What is the information error probability PE if the binary symbol error probability is Q is equal to 0.1? So this problem can be solved using binomial probability law. We can treat each transmission as a binomial experiment. So for example, if we suppose the transmitter transmits a 0 using these 5 symbols of 0, 0, 0, 0, 0, right? This is transmitter. Then on the receiving side, it can receive, for example, all zeros correctly, right? So that it is treated as a 0. Or there can be an error in any one bit, let's suppose here. So it is still treated as a 0 because 4 symbols are received correctly. 4s are 0, so it is treated as a 0. Or there can be error in 2 bits, for example, this way. So this is still treated as a 0 because 3 zeros are there and there are 2 1s. However, if another bit flips, for example, this one also, so there are only 2 zeros. So in this case, there is an error now. The received bit is in error now. This is treated as a 1, right? And again, also, if the number of 1s is 4 here, this is again an error. And it is also possible all the 5 bits flip, and this will also be treated as a 1. So in this case here, for example, number of failures is 0 and successes is 5, number of 5 successes. So this can be treated as a binomial experiment. So and each bit is a binomial trial, right, with a possible outcome of either 0 or 1. And these 5 bits, they constitute a binomial experiment, right? So in this transmission, for example, number of failures is 0, number of successes is 5. In this case, the failures is 1 and successes are 4. In this particular case, the number of failures is 2 and number of successes is 3. In this case, number of failures is 3 and number of successes is 2 only. And here 4 failures and only 1 success, and here all the 5 bits fail and there is a 0 success. So the error occurs in these 3 cases, right? So each case can be treated as a binomial experiment with 5 number of trials, right? And we can find the error probability for this binomial experiment, for this binomial experiment, or for this binomial experiment also. And we can then add them together to find the probability of error for the information error probability PE. So for example, probability PE is given by probability that only 2 bits are received correctly. C is equal to, for example, received 2 bits correctly. Let's denote this by C is equal to 2. Probability that only 1 bit is received correctly, or probability that no bit is received correctly, right? So each of these probabilities can be treated as a binomial experiment. So for example, there is a total number of trials is 5, so this is 5, and the number of received bits correctly is 2, so 2 successes. So exactly 2 successes in 5 trials is given by, now the probability P is 0.9 because Q is equal to 0.1, then probability of success P is 1 minus 0.1 is 0.9. So here 0.9 raised to the power 2 and 0.1 raised to the power 5 minus 2 which is 3. Then this probability, this is given by again 5 and 2 and 0.9 raised to the sorry, not 2 this time, the successes is 1, so this is 5 1 here, right? So 0.9 raised to the power 1 and 0.1 raised to the power 5 minus 1, which is 4. And then probability for C is equal to 0 only when none of the bits is received correctly. So that is 5 0 and 0.9 raised to the power 0 and 0.1 raised to the power 5 minus 0, which is 5. So we can now calculate all of these values to find out this probability PE. So this is 5 to 5 factorial divided by 2 factorial, 3 factorial, and 0.9 squared multiplied by 0.1 squared, 1 cube, plus 5 factorial divided by 1 factorial and 5 minus 1, 4 factorial, 0.9 raised to the power 1 and 0.1 raised to the power 4, and plus we have 5 and 0, this is 1 basically, but let's write it down, 5 factorial, 0 factorial, 5 minus 0 factorial, 5 factorial, 0.9 raised to the power 0 is 1, and we are left with 0.1 raised to the power 5. So 5 multiplied by 4 multiplied by 3 factorial divided by 2 into 1 is 2 into 3 factorial, right? So and 0.9 raised to the power 2 into 0.1 raised to the power 3 plus so this is 5 factorial divided by 4 factorial, so we're left with only 5 into 0.9 into 0.1 raised to the power 4, and this is 5 factorial divided by 5 factorial, this is 1, and this is 0.1 raised to the power 5. So we can now use our calculator to calculate these values. This cancels out and this left leaves us with 2. This is 5 into 2, 10. So 10 multiplied by 0.9 square multiplied by 0.1 raised to the power 3. So that gives us 8.1 into 10 power minus 3, right? And plus we have this term, which is 5 into 0.9 into 0.1 raised to the power 4, right? So this is 4.5 into 10 power minus 4, 4.5 into 10 power minus 4, and then the last term 0.1 raised to the power 5. So 0.1 raised to the power 5 is 1 into 10 power minus 5. So 1 into 10 power minus 5. So adding them all together, we'll get this probability, information error probability PE, right? So let us add this together. So 1 into 10 power minus 5 plus 4.5 into 10 power minus 4 plus 8.1 into 10 power minus 3. So that gives us 8.56 into 10 power minus 3. 8.56 into 10 power minus 3. And this is basically equal to 0.000 0.00856. So this is the information error probability. So it can be noted that the error probability for only a single bit is 0.1. But however, if we transmit a bit using 5 bits, then the error probability reduces to only 0.00856. Stated in another way, the probability of success when only a single bit is transmitted is 0.9. However, when a single bit is transmitted using this 5-bit symbols, then the probability of success is 1 minus this value, the answer, which is 0.9914. So the probability of successes increases by large value. So probability of success with a single bit transmission is 0.9 only, and with 5-bit transmission it is more than 0.99, which is quite a large value. So this concludes the solution to this problem.